Hello and welcome to lesson 2 in Spiral 4. Today's topic is specifically curve of best fit. So we talked about it a little bit about this in lesson 1. This one's dedicated to curve of best fit, and what we want to do is be able to identify and draw a proper curve of best fit. So just a bunch of examples that we can go through here. So I got two of them here, and basically the way you can look at it, if I draw a line, so pretend this is my ruler. When I go and try to draw a line of best fit here, you can see that there's no real good place to put it on the first one. So on the first question, the only possible solution is just like back in the good old days when you're doing connect the dots. All right, so that one forms a nice smooth curve, so I just free-handed it. If we were to look at the second one, and you're kind of like, oh, maybe a line of best fit, so I kind of bring the line in, I tilt it down, but now I have points up here. So then I move it up, and then it's like, well, that doesn't make sense because I got so many dots in a line here. You start to realize, you know what? This is really data that would be best represented by a curve. And you can see when you draw that curve, I can draw a nice smooth curve such that all points are falling on that curve. All right, so the first one, this is what we call a quadratic. You're going to see this in the grade 10 course next year. This one's an exponential curve, and that one you're going to see in the grade 11 course. All you need to do is be able to draw them. You don't have to do any work with them. This one again, you could almost see a line working here, but you see how it kind of makes a S-curve, and there's two areas of kind of a hump. Those two areas kind of indicate that we're definitely not dealing with a linear relationship in this case. So the line does not work here, and we end up with kind of a snake shape. All right? So it's basically from experience, but basically I look at the ruler, I put the ruler down, and if I'm not happy with the ruler, or that line of best fit, then I move on and see if I can draw a nice smooth curve. All right? Next examples here. So we look at the next examples, very similar to the middle one that we did over on the other page. Again, this one I can draw a nice smooth curve through all the points. So that's definitely the curve of best fit. If we look at beach visitors, this one's a different story. Again, can I see, and this is just to make you aware that you got to kind of think sometimes. When you look at this one, you know what? I can get my data inside a corridor here. So you know what? This one, I can actually use a line of best fit. So just got to be aware of and be thinking line or curve. So that's going to be a positive, weak correlation. So a positive, weak correlation. So don't get in the mindset that it's always going to be a curve or it's always going to be a line. All right. Next one. So the next one, again, you know what? I can draw a curved corridor. That's still valid. You can do that even with a curve of best fit. So the resulting line of, or curve of best fit, I should say, goes down the middle of your corridor. So that data there definitely should be represented by a curve. Moving along. Excuse me. This one again, when you go to try, if you bring your ruler out and try to draw a line of best fit, you can see it just doesn't work. All right. I can't make it. I can make the first part work, or I can make the last part work. But at the end here, when you look at this, it's not going to be that line of best fit. It should be a curve. All right. So with your pencil or pen, nice smooth curve, just like they teach you in art class. Hey, you can see that the majority of my data, it's actually a pretty strong relationship. The majority falls on there. This last one, very interesting. It's at first I'll have some people that will say that there's no relationship, and at the grade 9 level I probably would accept that as an answer. However, in grade 11 you get to see different functions. So if I was to draw a corridor that contains my data, so I'm just going to draw a corridor, and again it's not going to be a linear corridor. This actually gets you a form of what we call a sinusoidal function. All right. So we can represent this data using a curve of best fit. Now you don't have to worry about an equation, and this one's a little bit on the extreme side. What you need to decide about, and what your probably, like I said, level of difficulty would be one like this one, the one that's linear, and then one like this. So we try to exaggerate it a little bit to help you out. It's not like you're going to be sitting there going, well, is it one or the other? We're trying to exaggerate it enough, whereas this one's definitely a little bit more extreme, and I don't think I would put that perhaps on a test. All right. As we continue on, I've got a chart here, so let's zoom it back a little bit here. Hey, graph the following information and draw on the curve of best fit. So we have our months, so we'll go through and do this quickly. So 0, 1, 2, 3, 4, and so on and so forth. Going up, I got a max here of 15. So I'm going to go every square is 1. Let's keep it easy. So the first one's at 1 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's call that 10. So 1 and 9 right there. 2 and 9.9. Hey, that's 10, by the way, just for you that are paying attention. 9.9, I'm going to call that pretty much a 10. At 3, it's going to be 11. So close enough there. 4 is almost a 13. So 11, 12, 13. Then we got 5 at a 15. A little bit higher on the next one. And starts to go back down, so I'm at 14 and a half. Then down to 13. It's a lot easier without a smartboard because the marker pen's so large here. 10. And we're back down to 9. Oops. What did I do wrong there? 9's down here. Check that. I'll go backwards here for a second. Make sure I get them right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops. 5, 6, 7, 8, 9, 10, 11, 12. 12, 9. I should have ended there. So that would be a 10. Almost a 12. Well, I skipped 13. Something like that. All right. So there we go. We plotted the points that were given. I struggled with it. Hopefully you're a little bit better with it. So now we can draw the curve of best fit. There we go. Just draw that curve through there of best fit, and it's a month. And the nice thing is, if you think of it, if this is January, this is December, the next list down here is going to start at January and go to December. So it's going to repeat. It's going to repeat. So this particular curve then is going to go back up and repeat. So we can figure out, well, what's the pattern. All right. So from here to here represents 1 year. And then when you repeat the pattern, getting into your second year. So it allows you to predict future values as you move through. All right. So this is the month. This is the amount of daylight. So as we hit, peak daylight, approximately July, and December, January, that's when it's the largest nights. So now that I gave you a lesson on light and how much light we get during the day, this should allow you to go ahead and deal with some of the homework with curves of best fit. If you have any questions or need clarification, make sure you ask your classroom teacher. Good luck, and we'll see you in the next video.